Welcome to Physical Science in the AM. Thank you. I am. No, you're not the teacher. I am. Joel Sedai. Okay, anyway. Going through this. First equation is balanced. Going through this step kind of system. So, you got this out and you're making corrections as necessary. All I'm going to ask after you do this is 1 or a 2. 1. And getting there, not quite there. 2 is like, I think I could do, if I had another set of these questions, I could probably get 75% of that, right? So it's a 1 or a 2, meeting expectations too. Back in like elementary school. Anyways, talking about this. Balance the equation. Always scan an equation to make sure. Identify the materials you're working with. So you read this carefully. And I see that, okay, it's sugar. Like some of these things aren't things you write down. But I'm working with sugar and carbon. So I see that and I think to myself, it's this sugar and it's this carbon. The water isn't really used here. This is what I'm doing, right? That's not a crossing. And I'm teaching you a way to think about this. This is one, and it could have been phrased better by me, but if necessary, convert to moles. Let's read this. How many moles of sugar? Well, but the given information is grams, so I am going to have to convert to moles. So I'm going to start this up. 700 grams carbon. Now, I'll write it like this. This is ambiguous, as in, is it 700-ish, or is it 700 on the nose? And I won't deduct marks when it's those ambiguous ones, or whatever, whether you use 3 digits or 1 digit. Because you can say, well, that's anywhere from 749 down to 650. That's 700-ish, right? Hey, convert to moles. I want a mole, and I want to get rid of grams, and carbon is 12.01. I don't need my table, but I'll get it down here. Know that. If I stopped right now, I would have moles of carbon. I repeat myself because I say this all the time. Why? Because I want to get self-talking. What is the next step? Doing this in green. Set up the ratio for your 2 substances. I've identified which 2 substances. So I don't want in my answer carbon, but I do want sugar, sucrose. There's a lot of sugars. Sugar. Okay. Now, I want to put in the front numbers from the balance, because that's really the important part. But now, I've gotten rid of information about carbon. If I stopped here, I would have moles of sucrose, sugar, this sugar. And that's what I'm kind of mentally doing right now. Identify, what am I trying to find? Solve for your unknown. If it was moles of sucrose, I would stop right here and calculate, right? Not what I want, though. I want how many moles of sugar are decomposed. Oh, I do. Great. I will stop. We're done. But if not, you would have to go from moles to the desired unit. So I'm going back to this. So this is 700 divided by 1201 divided by 12 again. What was it? I'll see if I get the sense of it. Tell me. Go ahead. All at once. I don't care. 4.86. That's an entry. I didn't. What did you guys? Anybody get something different? So the way I'm entering this, and this is important. This is why I keep checking. Well, we all know times 1 doesn't mean anything. So 700 divided by 12.01. Then I'm going to say times 1 doesn't mean anything. Divided by the number 12. So I entered in as 700 divided by 1201 divided by 12. Oh, you know what? This calculator is crappy. I feel like throwing it out. It has, I'm not crazy. You see what I'm talking about, Maddie? The 4 on the front is straight through the display. You are 100% correct. This calculator is rubbish. Thank you. 4.86. The display has gone on. And that's the perfect number if we're going to assume that's 700 on the nose. 4.86. And it's moles. And it's sugar. By the way, have you guys talked about sugars and health science like this kind of formula? Okay. You will imbibe it if you take it. Okay. Now I'm going to run through the same kind of steps again. Balance the equation. This time I actually need to balance the equation. So I see, I just need a 3 here. I've got it balanced, right? Now, what am I working with? You can do metric, there's nothing right now. How many grams of magnesium are formed from 45 moles of magnesium nitride? Now I realize I was reading standing too fast. Magnesium nitride. So that's these 2 things. What I just underlined is, you can underline if you wish, but I mean, it's the mental check. And I want to convert to moles. Okay. I already have moles. So I'm going to do it right down to 45 moles. And that's mg. So, number 3, convert to moles in big moles. You always got to get to moles, but it's in moles. So don't think you need grams to moles right off the bat. Set up the ratio for your 2 substances. I want to get rid of information about magnesium. I want information about magnesium nitride. So I got 1 of those and 3 of those. If I stopped calculating right now, I would have moles of magnesium nitride. Let's move on and see. Identify my unknown. What am I trying to find? Well, grams of magnesium. So I kind of need to solve the. I could have stated 5, 6, 7 a little better. Anyways, convert the moles to the desired unit. I want grams. So you're not using periodic table. Convert moles. Big G here or big G small. And then I will go, I don't know what happened. The model, what I'm thinking, 3 times the magnesium, 24.31, plus 2 times 14.01 for the nitrogen. 100 decimal 91. Okay, I'm done. I just need to toss it into the calculator. 45 divided by 3 times 100.95. You guys always stop me to get something. Now, I am writing out what I got here. 42.25. But I'm not writing that down. I would only keep 2 of these significant digits, 1,514. Well, I'm going to go with 1,500, right? Significant wise, you guys still see that? Okay. You got to keep the place value. It has to be. Count. Okay. I forgot to update it 10 times. I'm going to pause it again. Okay, back on this. Pause screen. Now, this one. correct me for it, but did you notice it was in kilograms? So kilograms is a lot of grams. How many? Kilos or thousands? I have that up there, but you can always ask. So this seems goofy at first. Okay, I guess I'll go through in order. Balance the equation. Ooh, what do I need to do? Help me out. What do I need to do? Balance the equation. Tell me. One SI, one SI. So far, so good. Two O's up. No. So what do I do? Two. Okay. Now I got two carbons. Nope, I don't. Oh. Ha! I caught my own self. SiC plus C. I need to what? What do we do with carbon? I thought that too. 1, 2, 3 carbons. Like I said, I catch myself. I don't like just looking at equations. So I need a 3. I'm going to triple dog check here now. SI, SI. 2 O's, 2 O's. 1, 2, 3 carbons. 1, 2, 3 carbons. Okay. Don't expect, like, don't be discouraged if it takes you 3 or 4 minutes sometimes to do these. Balancing. That's it. Okay. Materials I'm working with, convert to moles. Okay. Now, I use the word weight, and I shouldn't have. When I type this up, it should have been mass, but mass of carbon grams. This one, though, I started with kilograms. So 1,000 times 3,500, I'm thinking 3 million. If you didn't and used 3,500 on there, it'd be out by 1,000. It'd still be a big number. Okay? Okay. Stuff is me. MAR. So I need to get rid of grams. I need to convert to moles because I didn't have moles. I need to add up SI plus C. So 29 plus 12, 0, 1, 49, 10. I stop right now. I've got moles of carborundum, silicon and carbon. I need to set up relation for my two substances. What am I trying to find, basically? So when I say sort of, I have this in blue initially, but really, I do these two things at the same time. So I get rid of SiC. That's a 1. I want information about carbon. This is sort of the next thing, identify what you want to find the information about. 3 carbons. Good. If I stop now, okay. If I stop now, I have moles of carbon. I want moles. Nope, I want weight, meaning mass, actually. So solve for my unknown, which kind of did, and convert to moles from moles to heat. So carbon, I use it. 12.2. Is this how we're set up? I'm asking this because throughout your calculations, sometimes you would say, yeah, but do I use the mass of C carbon or do I use the mass of 3 carbons? Never use the front balancing numbers to determine the grams per mole. It's C carbon. Let's follow that. Like, there's 1 of this grams per mole. That 3 is taken care of in my green graph. Anyways, 3 million. 500,000. divided by 49.1 times 3 times 12.01. Huge number. Obviously, I'm not going to keep all these digits. 2, 12, 6, 8, 3, 2, 9, 9. Okay. I really only need to keep 2 digits. So, what do I even call this? I'm going to put commas in here for my brain. Sort this out. 2,000,000. 600. 5, 6. Boost it up to 6. I'm going to go with 2, 6. That's grams of carbon. Okay. When you're talking about those kind of masses and stuff like that, like when you're using 3,500 kilograms, coming out with 2,600 kilograms, rounding off does make sense. Because industrial applications, you're not going down to plus 4. Now, I want, and I'll pause it. So mass-to-mass problems. We did one mass-to-mass problem already, that carborundum thing, where we started with kilograms to grams, and then we ended with grams. That's mass-to-mass. It'll involve 3 brackets, though. That's another thing. Okay? I realize now, though, that's not really red, is it? That's orange. So, it's not the same red, but I mean, you know me and colors. Anyways. Somehow I got screwed up. Anyways, that's not a big deal. So, these are the steps. Find the mass of potassium. You guys get enough? I hear noise. Okay. Find the mass of potassium chloride produced when 8.21 grams of potassium chlorate are decomposed. So this means we have to understand names. Chloride and chlorate are pretty close to each other. The chloride is KCl. You'd use your iron sheet if you didn't, but I think by elimination you know which one's the chlorate because it's the ClO3, there's one with potassium. If needed to, though, it's on the iron sheet. Okay? You have to not lose it. So we're using these 2 chemicals. We got a balance. 1K, 1Cl, good. 3 O's, 2 O's, crap. So we got a balance. So I'm going to go with this old 3 and 2. Now I've done these, so I see these little crooked. Like I've been doing these for over 3 years. So, like I say, don't be discouraged when it takes you 3 or 4 minutes to do something like you do. If we balance, identify the 2 materials I was underlining as useful. So, always start with writing down. Start with the material, starting material with units and formula. Yep. Oh, thank you. Total. See, I was talking. That takes me a second. Yeah, it didn't. And it was this. I think I've mentioned this before. I make way more mistakes when I'm talking at the same time. When I shut up and I'm just working on my own, I don't think about it. Thank you so much. That would screw us up. 2, 2, 3. So, always start with your given material. Typically, it's not a fraction. If needed, convert to moles. Well, we do need to. So, grams. Got rid of grams. Getting rid of grams. I got to use the periodic table. I know we added it up there big. So we're going to put in a K. I find it on the periodic table. 39 points plus Cl 35.41 plus 3 times 16 for the oxygen. I get 122.55. Okay, that's from the periodic table. You convert to moles. Then you set up a ratio for your two substances. Well, I'm getting rid of information. With potassium chlorate, keeping information. Oh, potassium chloride. Sure. The smoke is actually bothering me. Actually, it's my eyes. It's very subtle. Okay, back to the actual chemistry. Okay. Yeah, go. Okay. A K on the periodic table is 3910. Did I write? I'm just double checking my number. 35.45 for one group of Cl plus 3 groups of 16 for the O's. That's where I got it. Always keep on top of this, and it's best if you work along. Don't let me come out. Never the front numbers, but the numbers within a formula definitely have to. So we set up the ratio. Now, what do we find? In this case, we're finding grams. Sometimes that last bracket isn't needed if you only want mole. So I want grams per mole. And it just so happens that 3910 plus 3545 is 7450. I make mistakes, so I really need you guys to follow along with these things. 8.21 divided by 122.55 times 2 divided by 2. I recognize I don't need that, but you can. Times 74.55. I get 4.99. We did this the other day. So I wanted it set up. Okay. So this is how you're going to do this. Now this is quite explicit, but it's colored. It's got the steps right underneath. I am going to put the page, right? Turn the page. We've got some more set up like that. So the idea is then to work away from this and to get this in your hand. So you can use this as a roadmap to do the rest of the questions out. Now, someone at the back looked puzzled, wrote. But were you not thinking it wasn't the math that was puzzling you? Like you looked puzzled when you were looking at it, but it wasn't about this? Yeah, about 30 seconds. Oh, wait, it came through black and white. The photo. You get it, right? I am colorblind-ish, like that. I'm not black and white. I do that. Okay, that's a budget concern. Okay, balance the equation. Magnesium, magnesium. They so far so good. Ag, Ag. NO3. Remember, I've always said too, if you see an ion like this, I think of this as NO3. You don't need a bracket, but that's one group of NO3. This is 2 groups of NO3. I don't think of it as N and 3 O's. Okay? So I need a 2 and 5. Now that screws up my silver, but it didn't screw up my magnesium. I'm pretty confident I have this done. Okay? I know I have the 2 materials we're working with. I'm working, well, I got it done right. Okay. 50 grams of magnesium. I have 1 grams of silver. Remember, sometimes they'll say mass of silver, meaning measuring the gram. So we start with what? We need 50 grams of magnesium. I already have it written down for you. Yeah. Convert to moles. Well, golly, magnesium. Look it up. 24. 0.31. We're going to assume this 50 grams is two significant digit things and digits. I use the balanced reactions to put down 2 for the silver, because that's what I want. What I want to get rid of is magnesium. I think I got that. Set up the reaction for 2 substitutes. Good. What are we finding? In this case, grams of silver. Right? You got to think this through. So, silver, Ag. Why not be Ag? Why not S? Well, because S is already used for sulfur. Why not Si? Because Si is already used for silicon. Ag. It's not the only language. English is not the only language. I think it has something like Argentum or something like that. Latin. Anyways. Silver is 107.87. If you're ever wondering why some symbol is probably like K for potassium, it's not because it isn't. And it usually goes back to scientific Latin back in those days. You can always Google up why some elements may be what it is and have a mismatch. Divided by 24.3. 50 divided by 24.2 times 2. 107.87. 443.72. Okay, I can stop there. 443. I'm going to round that to 440. That's the proper way to do it. I wasn't scratching out as I did this. There we go. That's how I know it's grams, and it's silver. If I made a mistake. I'm going to mention this. When I started marking the assignment, the Bowles assignment, I actually didn't end up marking for significant digits. I still want you to, but I don't think we're quite there yet. And so the whole goal of marking for significant digits is not to punish people with decimal fives off here. It's to get you ready for your Chem 30 or business, right? So I want you to keep doing significant digits just because I'm not digging every time. Still do it because eventually the goal is that we will. But it's learning by doing gradually with it. Questions about this though? No? Okay. Well then, moving on. I've already identified the underlying things we want, but I got a balance. AL, good. H2. Whew. I'm going to do this in disappearing ink because I'm going to say, okay, now I got 2 Cls. Oh, or I mean, now I got 2 H's. But then, oh, my Cls. That's rubbish, right? I've got to undo that. That's why I disappeared ink. So, I think I can't use 2 there. Works for the H2, but this is going to screw everything up. I got an odd number, Cl3, and I have an even number of H2s. So, I think it's like adding fractions, 1/2 plus 1/3. I got to use a 6, like when you add 1/2 plus 1/3. The common denominator. It's the same math skill. So I'm going to go with 6 here, 3 here, 2 here. This is a knack you get after you do a few things. Now, I know I've screwed up the aluminum, but I want to double check everything else. I've got 6 hydrogens, 6 hydrogens. I've got 6 chlorines, 6 chlorines. 2 ALs, okay. That's what I was saying there, just so you see the logic. Okay. That one wouldn't take some people a few minutes. That's good. Starting material. Now, what I have down here is just a generic setup. I have nothing pre-filled in. So identify my starting material. 60 grams of aluminum. So 60. I'm going to assume that's 2 digits. Significant. Aluminum, Al. Really only know with certainty, though, that's 1 if I didn't declare it. Convert to moles. Well, I want to get grams out of 10. I look it up. aluminum. 26.98. Okay, I stop now. I've got moles of aluminum. I want to get rid of information about aluminum. I always think of get rid of. I look up the number 2. I want information about aluminum chloride, and that's AlCl3. I look it up. It's 2. This is a 2:2 ratio. Mathematically, it doesn't do anything. But I need to write this down so that it show me what the chemical is now aluminum chloride. I'd stop here if I wanted moles of aluminum chloride, but mass or grams. So I need to, middle states, I need to look at the grams. L, like I said, 190 plus 3 groups of 4. 3 times 35 4. 133.3. I'm going to solve. So I'm going to go to 60 and divide by 26.98. And multiply by 2, divide by 2. I really know. Times 133.33. 296.5. Okay. So I'm going to write that down tiny here. 6. Only to just, you don't need to do this. 5, 0. I got way too many zeros. I'm going to round it. You can either round it to 1 if you thought the 60 was 1 digit. I couldn't argue with that. 5%. Or 2 significantly. But you know what? It still turns out to be 300. Because the 6 should bump up. 300. This is ambiguous too, the way I'm writing. Grams, AlCl3. And I say this is ambiguous because is it 300-ish or is it 300 on? No. If you really wanted to communicate to me that you think it's 2 significant digits, you use 3.0 times 10 to the 2. That's it. You want to communicate with me that is 1, you just say 3 times 10 to the 2. The scientific notation only lists significant digits. Okay? Now, I'm not going to expect you to do a bunch of homework, but I expect you to do in the next 6, 7 minutes a start. I'm going to pause the video. Actually, I'm going to stop the video. But we're going to have a work class tomorrow on this and another sheet. I'm not going to expect this to be homework, okay? But you do need to get one started. So I'm going to actually stop the video.